Welcome back to Lesson 6 quiz. We're going to go ahead and get started on number 3, and it asks us to select the correct reinforcing steel placement for a retaining wall. I'm going to go ahead and draw this in there. Oops, I'm not on the right tool here. There we go. This is a cantilever wall. Obviously, it's not the most perfect drawing in the world. Let's switch colors just to keep you guessing. And here's the earth, which they show it like this. The cross hatching. You can do it whatever way you want. And then, there we go. Alright, and it's asking us to select the correct reinforcing steel placement for a retaining wall. Well, tell you what, I'm just going to draw it in there, what I think would be the correct placement, and then let's see where it matches. Alright, so let's figure out pretty much what you want to do is you want to take it and say, okay, I'm going to cut it here, I want to cut it here, and I want to cut it here. And your heel, toe, and your stem. Alright, toe going into the lower side, heel going back into your taller side, and your stem going up. Alright, so let's do the stem first, which I usually will do first. And if you think about it, just cutting it, you're going to have a pressure wedge that looks like so. So your moment is going to be like so. If you think about it, maybe that doesn't, I'm not drawing this the best I can. So if you have something like this, and the moment's coming like that, it's going to bend it like that. So it's going to bend it like so. So you're going to have compression on the outside, and you're going to have tension on the inside. So you want to go ahead and, let's use pink. You'll want your reinforcing to sit right here. And I'm going to stop it right here to see which way we want to go with this. Because sometimes you have to develop this bar anyways, so you might as well use it and go with whichever way you need to, whether that be right here or down there or wherever it needs to go. Maybe down here, because we don't know where it needs to go yet. Sorry if I explained where it should go beforehand. If I give you a hint. Alright, so we know that this needs to be on the inside face because it's going to deflect like that. When we know that this is going to be compression on this side and tension on this side. So we want to put the reinforcing bar, because that's what the steel does. It's for tension, and the concrete is in compression. Alright, so we put the tension on the inside, or steel on the inside. Now let's think about this, and you want to maintain this right angle. Let's pretend that it's a right angle, and that's wanting to go this way. That means this. If this is going like that, then this one will want to go like this. So let's look at the heel. And we just said the heel is going to want to maintain that right angle. So it'll bend like that. So if that's happening, we're going to have compression on this side and tension on this side, so we want it on the top. We want the reinforcing steel on the top. And you might call it main reinforcing steel, because sometimes you'll call it temperature reinforcing steel, or control cracking. You might put reinforcing steel on the other parts of your. But this is what I would call main reinforcing. All right. And then we have the toe here. So if this is going that way, we want to maintain this right angle. If it's wanting to bend like that, then this will want to maintain the right angle, so it'll bend like this. And I hope that makes sense. So we'll have compression on the top and tension on the bottom. So we want to put the reinforcing steel on the tension side, which is the bottom. Alright, so there we have it. And when you look at it, what does this match up the best with? Let's look at letter A. It has it on the front side. It has it on the top, but it doesn't have the bottom steel on the toe. So I'm going to say, or actually it does yeah, I'm sorry, I was looking at B there. It has correct on the stem. It does not have the correct on the heel. So A is no. Go down to B, and B has the stem is incorrect, so that's automatically incorrect. Let's go to C. The stem is correct. So the stem is correct. The toe is correct, and the heel is correct. And the same thing with D. So they're both kind of what we said here, where we need the steel. So we have to take a look at those two and say which one is a better arrangement. And I will say that you want to go back to I'd go back to page 109 and see what they have there. And as you can see, they took the stem reinforcing and they went this way. And they took the heel reinforcing and went into the stem, like so. Could I justify that the other one would work? Yeah. I could say I don't think it would be incorrect. I think this is the better way to go about doing this. This is the better way. D is the better way. Let's say that. So let's have the answer for 3 be D. Let's move on to number 4. I think I said page 109. I actually had my pages out of whack, and it was, I believe, to be page 112. So go back to page 112 and look at those diagrams, and you'll see the reinforcing and how it looks like. And I think that's just a better way to lay out your reinforcing. All right. Moving along, we have number 4 again. It's tilt up walls. So I guess you have to pick which one is correct. So let's just start with A. Are present precast reinforced concrete walls with an H-T ratio of 25 or, and they are precast reinforced concrete walls within, but I am not aware of any H-to-T ratio of 25 or less. I'm pretty sure they could possibly be higher than that. So I'm going to say maybe on A. B, often function as deep beams spanning between footing pads. And that could be correct. C, may not be used as shear walls. And that's incorrect. They can be used as shear walls since they're pretty heavy duty if you design it to be. And then D, so it's not C. D must be at least 6 inches thick. That's incorrect. I know they can be thinner than that. So we have, oh sorry, my microphone thing was up there. I'm going to go with, let's look at the answer actually. It is B, often function as deep beams. And I guess because that H-to-T ratio is incorrect is why A is incorrect. Alright, so 4 is B. Let's move on to 5. 5 is, which of the following statements about wood stud walls is correct? I'm going to try to, erase this stuff while I'm looking. Number 1, platform framing tends to minimize total vertical shrinkage. And if you look on page, oh shoot, what page was that? Of course, these are just read the things, and you can go look at, it should be on page, sorry. Anyways, oh, there it is. Look on page 104. I might be wrong on this, but it says equalize but not minimize. So that is incorrect. Number 2, balloon framing is preferable where exterior walls are faced with brick veneer, and that is correct. So 2 is good. Let's go ahead and write that down, I guess. 2. 3. If properly detailed, wood stud walls may function as bearing walls, shear walls, or retaining walls, and that's incorrect because retaining walls, they do not. And it's mainly, I guess you could make a retaining wall out of wood for strength-wise, it could work, but you don't want to put wood up against, I think you all know this, you don't want to put wood up against earth because termites and rot and whatnot. So that's incorrect. 3 is incorrect. Let's move on to 4. In balloon framing, the studs are continuous and full height, with the second floor joist bearing on a continuous member that is let into the studs. And that is correct. Once again, look through those balloon framing and platform framing.
I guess I don't want to try to explain too much here. And number 5, so that's 2 and 4. Number 5 says wood stud walls are not required to have a continuous concrete foundation except in areas subject to ground freezing and thawing. And I'm going to say that that is generally incorrect. I guess you could in certain situations, but once again, you don't want that wood exposed to the ground, and you're going to want to have, the sill plate connected to the continuous foundation, and that's just typical. So I would say 2 and 4, and the answer looks like C can be 2 and 4, so we'll go with C. All right, moving on to number 6. And number 6 says select the incorrect statement about reinforced masonry concrete construction. And remember, it's the incorrect statement, so if it's right, it's wrong, if that makes any sense. Not to confuse you. All right, A, reinforced brick masonry is generally stronger than reinforced concrete block masonry. That's correct. So that means it's not the right answer. So let's move on to B. In reinforced brick masonry, horizontal reinforcing bars are placed in the mortar joints between the brick units. I have never heard that being done, so I'm going to say that is our incorrect answer. I'm going to circle it, and I'm going to read over C and D, just to make sure that they are correct. The grout used in reinforced masonry construction must have a minimum compressive strength of 2,000 psi. Sounds good. In reinforced concrete block construction, cells, in contrast with the earth, should be filled solidly with grout. That makes sense as well, so the answer is B. Moving on to number 7. Select the correct statement. A, reinforced concrete walls are able to resist axial compressive loads, but not the bending moment. That is incorrect, and I think I shouldn't have to say anything about this, but it's saying that it can't resist that type of action, or the smile type of action. If you have... Actually, those should be on the other side, but that's all right. And that is incorrect, because it is, you put that reinforcing in those reinforced concrete walls. But that should have been obvious. All right, so that's incorrect. Going on to B, reinforced concrete walls must be anchored to all floors and roofs that provide lateral support for the wall. That seems to make sense, yes. I guess you could have a cantilever wall, but that would say all floors and roofs that provide lateral support for the wall. So if I guess that's kind of confusing. I'm not a big fan of that wording exactly. I would say most likely that is our correct answer. Let's go on to C and D. Openings in the reinforced concrete walls are usually framed with steel angle lintels, and I'm going to say that's incorrect. Reinforced concrete walls are often pre-stressed to prevent tension cracking, and that can happen, but often, and that's another wording I don't like. It should be just definitely false. Anything that's not right should be completely wrong. And you can have reinforced, I guess, pre-stressed concrete walls are pre-stressed to prevent tension cracks. And I hope that makes sense. I don't think we've ever gone over that before. I mentioned what pre-stressing kind of does, but not the purpose for pre-stressing a wall. And you have a concrete wall, and you're pre-stressing it. So you take this, and when they pour these things, since it's pre-stressed, they'll tighten it. They'll pull on it. And then once they pour the concrete and it sets, they'll cut these or let them go or however they do it, and it'll kind of, it's like a rubber band. If you squeeze the rubber band, once you let go of the rubber band, it'll want to come back. And all that, how the reinforcing bar has these grooves in it. And I think you can look at it earlier in this section, and I'll have pictures of the two where it looks like that. That's a bad picture, but the point is it's got things that grab onto the concrete. So it'll actually bring all this, it'll be pushing this or pulling this concrete in, and therefore it will crack less. And that's a good thing. You don't want less cracks. And even if it does crack, it's going to push that crack together, so not as much water gets in, and it lessens the effects. So the answer on this one's B, and I will see you on the next part of this Lesson 6 quiz. Thanks.